4-2 and 4-1 formative. If you're watching this, you probably care about your grade and you're curious how these problems are done. So kudos to you for showing up and being here on this video whenever you end up watching it. There's an unknown number of people at the table at the beginning of lunch. Then each student had 2 friends, small typo, come sit with them, tripling the amount. So when I think triple, I think that there's probably going to be some number X and then 3 versions of it, because I'm tripling the total number of students that are there. I then have 5 people leaving the table. So that usually means a deduction. So we can put that together as 3x minus 5. And then finally, the total number of people at the table was 10. So that's going to claim that 3x minus 5 equals 10. That's the equation you would use down here. You have a few options with how you can solve the number of students that were at the table. You could undo the equation and work backwards, or you could solve the equation. Let's see what options we have. For the equation, this is a 2-step equation. So think of this using SADMAP, where in the first step, you're most likely using subtraction or addition, and then division or multiplication. So this is going to be getting rid of the 5, thinking opposites here. Remember, think opposites, claiming 3x equals 15. Divide both sides by 3. So I ended up using addition and division. X equals 15 thirds, which is really just 5 people. So 5 people were at the table at the beginning. If you're not convinced, you could try to plug it in to the equation and it'll produce a true statement. We then have a little bit more going on here, nothing we can't handle though. Each person had 1 friend join the table, doubling the amount, so that's 2x. The entire group divided into 3 groups and all but 1 group left, so only a third of the total people were left in the game. So when I think a third, I think a fraction of what was there before. So I'm thinking that this is 2x multiplying by a third. Or if you want to rewrite it to 2x over 3, that's even better, I think. 1 more person joined the game just before the end of the game. So this is 2x over 3. Then 1 person joins the game. So we add them in, but outside the fraction, because the fraction's kind of done, total number equals 11. All right, so there's an option here that should say 2x over 3 plus 1 equals 11. This is also self-checking, so use that to your advantage. Lo and behold, it's correct. If we work backwards, originally we were adding 1 student, but now we should be deducting 1 student from both sides, getting you 2x over 3 equals 10. Back here we were multiplying by 1/3, but now we should be dividing by 1/3, or in this case, multiplying by 3. Again, think opposites here. 3's cancel, you're left with 2x equals 30. Divide both sides by 2. The undoing of multiplication right here. X equals 15. And this would be 15 people playing softball. There you go. Let's keep it moving. We're undoing this equation. I think sometimes what helps is to think about how X got into that position. Like when I look at this, I think that X was probably multiplying by 4 and then dividing by 5 and then subtracting 7. So think opposites when you're undoing that. So I would be adding 7 to both sides. I would, well, first read through the problem if you need to, so you understand what's going on. I should have done that. I'm adding 7 to both sides. That would get 4x over 5 equals 20. And then I see division here, but I want to use multiplication and get rid of it. So let's see that second. And then divide by 4. Lo and behold, X is now isolated. And so if we were going to go through solving this, follow the steps that are here. We already added 7 both sides. If we multiply 5 to both sides, that step's done. This is now claiming that 4x equals 100. And it's important to keep it 100. Divide everything by 4. X equals 25, staying alive, bacon and chive. Boom. Boom, 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 boom. Boom, 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 boom. And tell me what you're gonna do when you're solving for X. Okay. Everything's dividing by 2. Undo it by multiplying by 2. (3n) is now adding 15, but it is equal to negative 60. Two-step equation here, use SADMAP. Think opposites, deduct 15, deduct 15. So I used subtraction here. Now 3n is claiming to be equal to negative 75. Divide both sides by 3. N equals negative 25. Boom. Boom, 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 boom. All right, solving this, 5 is multiplying with everything in here of k minus 1, claiming it's equal to negative 45. I saw a few students trying to take the approach of distributing in 5, but you'll soon see that the steps here aren't going to match that. So that is an option if you're so inclined to do it, but it might be something to hold off on. Yeah, so the option you do have is to distribute, but you don't necessarily need to. One thing I would do first is read through the problem. In this case, we're trying to solve for k. Getting rid of the 5 is a good look because 5 is multiplying with everything here. So if you divided both sides by 5, it gets you k minus 1 equals negative 9. You can then take this further. Eventually, x is going to be isolated, but you should add 1 to both sides first. So the one step we did into was multiplying everything by 5. So remember, the one step's not needed. If you add 1 to both sides, k is going to be equal to negative 8. Boom. F and T, well, we see F is just adding, well, F is the runs scored in the first game. So you could really just, no, not that. You could truthfully just copy and paste and then just think what operations being thrown in. Plus runs scored for T in the third game. Down here, use words to tell what the following expression means. This is taking the total runs for the first 3 games and deducting the runs from the third and second game. So really, this is just leaving runs from the first game. So this could all be rewritten as A minus T minus S equals F. And that's correct. Boom. Literal equation solving for B. B is right here on its own. MX is holding us back. MX is positive, so just deduct it. You don't see any like terms here. You're not working with another MX term, so just write Y minus MX equals B. Call it a day. Done. Only took 1 step. You should be well versed if you were going to have to solve for M or X though, so be careful there. Here you're solving for X. So you're trying to get X on its own. So move this 3Y over. Remember, think opposites. So deduct it. 2x is left. I'm going to put negative 3y first. Hope that's okay with you. And then divide everything by 2. So then x is equal to all this. Bonus thing, you could have written this also as negative 3y over 2 minus 3. Because right here, this is 6 over 2. So something to ponder. That's it. If you got any questions, reach out. Thanks for watching.